First, we will discuss about the
Yeah, it is used to check the duplicate IP within the LAN.
yeah proxy. Suppose it's a network here, router
Sir,
one.
your screen is visible.
Sir, your screen is not visible.
Not visible. Now is it visible?
Yeah.
Yes, sir.
Here R1 and R2, different networks, two different routers, and PC1 and PC2 are two different PCs in different network. PC1's IP address is 10.0.0.1 and router R1. Abdul, what will be the subnet mask if I am using here 254?
Wait, 254 is 255.255.255 subnet mask, right? For this
Yeah,
252 one, I think, right?
subnet mask will be 255.255.255.0. Here suppose it is 12.0.0.254. Here suppose it is 12.0.0.1. Guys, it is clear. So PC1 want to send a packet to PC2. So first of all, what PC1 will do? PC1 will generate a ICMP echo message, and in which source IP address will be
10.10.10.0.0.1.
destination IP,
12.0.0.1.
source MAC. Suppose it is 0A, it is 0B. Routers, each and every interface has a different MAC. OC, OD, OE, OF. Note down this point. Router, each and every interface has a different MAC address, and we can change the MAC address of the router interface with some commands. Okay, guys, I will tell you the command. Source MAC
Yes, sir.
0A. Destination MAC. Do you know the destination MAC?
No, don't know. Zero, zero,
Zero.
Router. I think it's gonna
zero.
be the first router IP, the gateway, I think. Right.
No, you don't know about the 12. Our destination is 12.0.0.1.
Yeah, that's why we are considering this R1, right, as a destination.
Yeah, but here, first of all, we need to generate an ICMP packet. So,
Okay.
do we know about the
Not
destination MAC? No, we don't know. That is why we are using here. So, first of all, what is required to us? Destination MAC. Without destination MAC, this ICMP packet cannot go from this router to this PC to this router. Okay, is it clear for everyone? So this ICMP packet will be on hold. And what PC will do? PC will generate an ARP request. But it's an interview question. PC and ARP request cannot send by any router or any PC from one network to another network. Every ARP request and ARP response work only within a network. Means if PC1 is generating a request for the ARP request to get the it will only can generate PC1 can generate an ARP request to get the MAC address of this interface only. It cannot send a request for OD, OE, ROF or OB because this request cannot send from one network to another network. Is it clear? An ARP request cannot travel in two networks. It will work only within a network. Is it clear for everyone? This point. It's an interview question. That is why
Yes,
Yes,
sir.
sir.
that is why ARP is a layer 2 protocol. It work on the layer 2. But why we called it as a 2.5? Because routers also use ARP request to and ARP response to get the MAC address of the different router interface. And router is a layer 2 device or layer 3 device? Venkat,
Yes.
Yeah, layer 3.
layer 3. So that is why ARP is called as a 2.5 layer protocol. But there is no existence of 2.5 layer in OSI model. So we cannot say 2.5 ARP is a layer 2 protocol. Okay? Is it clear for everyone? You guys can give the answer in the interview. It's an important question for the interview. Anyone has any doubt, he can ask to me right now so that I can explain and I can move ahead. Guys,
Sir,
yeah,
like if PC1 generate ARP request, then it will reach only router one, that default gateway, that MAC
default
address
gateway,
0C.
only
Am I
on the
correct?
default gateway, not to the other network. It will work only within this network, not beyond
Yes, sir.
that.
Yes, sir. Understood.
Understood?
Yes, sir. Understood.
Abdul,
Yeah, yeah, got that. But we are not looking at for the different subnets, right? We are looking for the different networks right now, right?
different subnet and different network are same terminologies.
Hmm.
There is no difference between different subnet and different network. Subnet means a network means a subnet.
Hmm.
Okay? So here PC will generate an ARP request. Does the PC have the information of the default gateway IP address? Every PC has this information. Do you guys know? Have you ever configured the default gateway in your packet tracer PC?
Yeah.
So,
Yes, sir.
so what PC will do? PC will generate an ARP request. PC will generate an ARP request in which source IP is 10.0.0.1. Destination IP is 10.0.0.254. Source MAC is 0A. Destination MAC is all 0. And now this request will reach to router R1. And router R1 will check that source IP is this one and destination IP is my this interface. And from the type and code, it will understand that it is a ARP request message. Guys, did you get it?
Yes, sir.
So what the router 1 will do? Router 1 will give a ARP response. Now a ARP response in which source IP will be. Abdul, what will be the source IP? Router 1 is giving this response to PC1.
So source IP is going to be, I think, R1 IP address.
Yeah,
The default.
R1 IP address. Great. 10.0.0.254. Destination IP will be
10.0.0.1.
source MAC
0A.
destination. No, not 0A. See in the graph here it is
It,
0A and here it is 0C. And R1 is giving the reply. So what will be the source MAC?
Is it OD?
OC for this interface.
Yeah, this. Yeah,
Did you get it?
yeah.
Source MAC will be 0C. Destination MAC 0A. And router will enter this 0A information in its MAC table, ARP table. Okay, guys, is it clear for everyone? Now this packet will reach to PC1 and PC1 will get the default gateway's MAC address and PC1 will store this default gateway MAC address in which table? In its ARP table. Okay. Now PC1 knows about the default gateways MAC. So again PC1 will generate a packet ICMP echo. Now this ICMP packet which firstly generate for how many seconds a ICMP packet can be hold? Yesterday I told you guys
2 seconds.
only
2
for the
seconds.
2 seconds. So if this process to get the answer of the ARP response from this interface is taking more than 2 seconds, then what will happen? This ICMP packet will drop and again PC1 will generate an ICMP packet. And now this time source IP will be Subhajit.
0A.
Source IP will be
10.1.
destination IP.
10.254.
No, 20.0.0.1. What will be the source MAC, Lakshman?
0A.
Destination MAC?
Destination MAC, it will be in hold like 000.
No.
No, the
Here,
default gateway is
what? Here not PC will
default gateway
use
is
that destination MAC, the MAC address of the default gateway. What is the default gateway's MAC? 0C. Abdul and Venkat, is it clear for you guys?
So, could you please repeat the one, please?
Which point?
This destination mark default gateway, first packet is dropped. Okay, in the second packet, destination mark will be default gateway. Is that right? You're saying?
Yeah, it is correct. So now this ICMP packet PC1 will generate, and this ICMP packet will reach to R1. This packet will reach to R1, and what R1 will do? First of all, it will see the source MAC and destination MAC. So it will see source MAC is 0 and destination MAC is 0C. So at layer 2, router 1 will understand this packet is for me. But when it will decapsulate on the layer 3 information, that source MAC and destination, source IP and destination IP, then it will see the destination IP is 20.0.0.1. So router 1 will understand that this packet is not for me. This packet is for which destination? 20.0.0.1. Is it clear, guys? Guys, is it clear?
Yes, sir.
yes, sir.
By seeing this IP address, router will understand this packet, this ICMP packet is for not for me. This is for only for this is for this IP address. So what will router 1 will do? Router 1 will put this packet, R1 will put this packet on hold and will see in its routing table either 12 network. Here I am saying 12, 20, so it's a 12, it's not 20, sorry. Don't be confused. Okay, so either this 12 network is present in my routing table or not. So once the router will check its routing table R1, and it will get that yes, 12 network is present in my routing table. And from which interface? On which interface it is connected? It is connected on this interface. Let's suppose this interface is gigs 0 by 1. So what the router will do? Router R1 does have the information about the 12.0.0.1 MAC address. Does it have?
No.
No. So what
No.
router 1 will do? Router 1 put this packet ICMP packet on hold and generate again an ARP request. In which in this ARP request, what will be the source IP? Source IP will
Router 1.
be this IP 11.0.0.1. Anyone, if not able to grasp any point, he can ask to me.
Sir,
Yeah,
not understand, sir.
which point should I explain for you?
After it generate the packet that with MAC address 0A and 0C, like after this packet, sir.
So this packet, did you understand here destination MAC is 0C?
0C, yes, sir. Now, yes, sir. It's understand.
This so this ICMP packet will reach to where?
Hello,
Hello, I am
sir.
asking this packet generated by PC1. This packet is generated by PC1 will
Yes,
reach to
sir.
where?
Router 1.
Router 1. On
Yeah.
when router 1 will open this packet, what will it see? This is the source MAC address. I
Yes.
told you guys when I discussed the OSI model that if it's a sender and it's a receiver, then when sender will send, then it follows this path from layer 7 to layer 1. Okay, but when receiver receive and open this packet, then it follows this path. First it will open the layer 2 information, then it will open the layer 3 information, then it will open the layer 4 information, then it will open the layer 5 and so on. So first of all, when router 1 will open the source IP and source MAC and destination MAC, it will understand this packet is for me. Lakshman, is it clear for you?
Yes, sir.
But
Yes, sir.
when for the layer 3 information will see router, then it will see the 12.0.0.1. Either 12.0.0.1 is present on any interface of this router, 12
No,
network.
sir.
No, it will understand this packet is not for me. It will understand this packet is not for itself. This is for the any other router or PC. Okay, so what will
Sir.
router 1 do? Router 1 put this packet on hold again. Here I have written down this point. Abdul, did you get the point or confused anywhere? Subhajit, Venkat,
No, sir, it's fine.
Abdul, Venkat.
Yeah, it's clear.
Okay. Now, Lakshman, is it clear for you?
Yes, sir. Now it's clear.
So, what will router 1 do? Router 1 put this packet on hold and generate an ARP request. So, in which ARP request source IP will be the interface, this interface IP.
11.0.0.
And destination IP will be 12.0.0.1. Source MAC, source MAC,
The MAC address of that port 11.1.
0D.
Oh, okay.
Destination MAC,
Unknown.
is it clear for everyone?
Yes, sir, clear.
So here router 1 will generate a packet, and this ARP request will come to on which router, on which device, from from this link. This information will come to R2. Okay, Lakshman?
Yes, sir.
And R2 will see what R2 will see.
R2 will see its MAC address first.
MAC address. It will understand this packet is not for me. Then on layer 3, it will understand this packet is for 12th network. Okay?
Yes,
Then
yes, sir.
what R2 will do, R2 will give a reply to R1. Reply to R1, in which R2, what will be the source IP address? This one will be the source IP address.
Yes, sir.
And destination IP,
11.0.0.1.
source MAC,
Source MAC
OE,
0E. OE. OE.
destination MAC, OD,
OD.
OC,
OD.
OD. Okay. So, but Lakshman, this is the most important point. Whether it is the right answer, R1 is asking for destination MAC for this IP address, not asking for this IP address. Am I right?
Yes, sir.
So whether this information is correct. So suppose
No, sir, it's not.
Venkat is asking to you that tell me about your father name. If you are uh, Venkat is asking to you what is the father name of Subhajit. Okay,
Yes,
and you are
yes,
telling
sir.
to him that what is your father name. So it's a
Yes, sir.
right
Understand.
answer or wrong answer.
Wrong, sir. Wrong answer.
This wrong answer it's called as proxy R.
Yeah, yes, sir.
Means it is asking for the MAC address of 12.0.0.1 instead of providing the MAC address of 12.0.0.1, it is sharing the MAC address of itself, router R2. This is called as it is ARP reply. It's
Yes, sir. It's a ARP reply.
ARP reply. So this ARP reply is called as the proxy ARP. Now proxy ARP is clear for everyone? Guys, Subhajit, Abdul,
Yes, sir.
Venkat.
Yeah.
Yes.
Abdul, are you
Sir,
there?
sir, proxy RP definition. Like
Maybe Abdul
correct
is not there.
definition.
Yeah, we'll give you the definition. Don't worry. But now you have understand. Did you understand?
Yes, sir. Now understand, sir.
So in simple word, proxy are if a router or a device, layer 3 device, which is asking for a MAC address to another L3 device, but instead of providing the uh, correct MAC address of a PC or a L3 device, if a L3 device is sharing itself MAC address, then it's called as the proxy.
Yes, sir.
Okay, I will share you the uh, notebook definition with you. Don't worry about that. But here you
Yes, sir.
need to understand this point. What is exactly a proxy? Subhajit and Venkat, guys, any
Yes, sir.
doubts?
Understand.
Understand?
Nothing about.
I think
Yeah.
Abdul is not there. Can anyone ask to Abdul to join the class? Okay. Lakshman.
Yes,
So
sir.
when router 1 will send sorry an ARP request to R2 and router 2 is responding itself MAC address, then at the same time router 2 will search in its ARP table either I have the MAC address of this what is the PC's IP,
PC2.
PC2
Uh,
IP or not.
12.0.0.1.
Then it will get no, I don't have the MAC address in my ARP table. So then router 2 what will router 2 will do? Router 2 will search either 12.0.0 network is present in my routing table. It will get yes, it is present in my routing table. Okay. So router 2 what will do? Router 2 will generate an ARP request here. Router 2 will generate an ARP request to PC2 to give me the reply of your MAC address. So what will be the ARP request? Source IP will be Subhajit.
11.0.0.
No,
Is that OF IP address? I think so.
from this
OF.
interface it will generate.
Uh, yes, sir.
So source IP will be 10.0.0.254.
12.0.0.254.
Destination IP
12.0.0.1. Sir, you have wrongly mentioned that 12.0.0.1.
is it correct right now? Source MAC
OF.
and this one source MAC OF.
OF.
OF. And now this ARP request will reach to PC2.
Sir, I have one doubt.
Yeah,
Like in our request, destination MAC address, if not known, then it will be like FFF. I think so. Whether it's correct or wrong.
it will be 000, not FFF. FFF in the case when switch will broadcast it. But you know
Oh,
router doesn't broadcast any messages,
yes, sir. It will unicast
unicast. So it will be always
000.
0. Is it clear?
Yes, sir.
Okay. Now the R2's ARP request will come to the PC2, and PC2 will give a ARP response to R2. And what will be the ARP response? Here PC2's ARP response, source IP will be
12.0.0.1,
destination IP will be
12.0.0.254,
source MAC will be
source MAC will be 0B, OB,
OB, destination MAC,
OF.
and this response will come to R2, and R2 will see destination MAC. When it decapsulate it, then it will found that this OF is my interface and this information is for me. So this OF router 2 will save in its ARP table that 12.0.0.1 device MAC address is 0F and it is present gig 0 by 1 interface. Okay,
Yes, sir.
Venkat and Subhajit, every point is clear?
Yes, sir.
So here router 2 get the MAC address of this, and now router will R1 will again send a ARP request. After receiving the proxy ARP request, router 1 will understand that router 2 has the information about the R2 in its routing table. Okay?
Yes, sir.
Because if R2 doesn't have the information in its routing table, it simply discard the packet. It will not give an ARP reply. Guys, suppose it's 12 network is not present in router 2's routing table. So once the router once send an ARP request to R2, will the router 2 give a reply? No, it will not give a reply. Why should it give a reply? Because it will understand destination IP is not present in my routing table, so this packet is not for me. Okay? Now, router 1 will again send a ARP request in which source MAC, source IP address will be, source IP address will be
10.0. No, it will be like 11.0.0.1.
Destination IP will be
12.0.0.1.
source MAC.
OD.
Destination MAC.
OB.
No. Router 1 does no. Did the router 1 receive any information about this OB?
Yes, sir. Yes, sir. Yes, sir.
No.
It will like
It will put the
0, 0.
router 1.
Router 2 MAC address.
Okay.
Oh, 0, 0.
Okay.
Yes, sir.
Now this
Yes, sir.
packet again received by the router R2. Source MAC address, destination MAC address, and when this destination IP router 2 will see, router 2 will check now in its ARP table and it will found this IP address, MAC address is present in my ARP table.
Sir, one doubt. Router 2 will have ARP table or like routing table. Otherwise, it have both.
Both.
Yes, sir.
Every routers have both table, ARP table and routing table. Okay.
Yes, sir. Yes, sir.
MAC address information will be in ARP table. IP address information will be in
Routing table.
routing table. Clear?
Yes, sir.
So now here router 2 will reply to router 1. Now it will give the information of router 1's it will forward the ICMP packet to PC2. Guys, are you there?
Yes, sir.
Until this point, all the things are clear?
Yes, sir.
So now R2, R1 again generate an ICMP request and it will reach to the R2 and R2 will forward this ICMP request to PC2. And now PC2 will reply to R1. And finally, PC1 will get the information of destination MAC address of PC2. The same process will go on. Here I am skipping 2 points, 2 more important points. I am skipping and we'll discuss it on Monday because it's a too large point. But I want that you guys till the end of this class can understand the proxy R and how a router can get the information about the other networks MAC address. So did you guys understand it? Proxy R?
Sir, one proxy or understand, sir.
Yes.
Like when packet, like when PC2, like when
Yeah.
router 2.
I will tell you how PC2 will reply and PC2's MAC address will reach to PC1. I will tell you in the next class.
Yes, sir. My question is like when router 2 sends this, like get the information of PC in the mid. You said no, sir. Like it will send proxy or R2 will send the proxy or request to router 1.
Mm.
Next, in the meantime, router 2 will generate ARP request to PC2
Yes.
to find the like. After that, what will happen? Like I got stuck from that.
Yeah. PC2 will reply. ARP request reply.
After
PC2 will
Now
reply
this is
and R2 will store the PC2's information in its
ARP table
ARP table.
MAC address.
So
And
this
after
point
that,
I discussed only to teach you for the proxy ARP, not for the packet flow. In next class,
oh,
the I will discuss the entire packet flow. So how PC2
yes
will
sir, yes
reply
sir.
and how PC1 will get the MAC address. Because if I will start, then it will at least take from here 1 hour.
Okay sir, okay.
Okay. So in the next class, I will
Yes
discuss
sir,
it. Don't worry about that.
yes sir,
I
yes sir.
discussed this point only to teach you the what is the proxy app. I can tell you the proxy app in a very simple way, but you guys will not able to understand that if I am giving directly R1 and R2 example.
Yes sir.
Okay, I explain it only for the proxy app. So two things are clear for you guys: recursive lookup and proxy app.
Yes sir. Clear.
Okay. So the next thing is, did you guys get why ARP is a 2.5 protocol? Because it's a very important interview question. It can be asked on the experience guys also. Guys, did you guys get the why ARP is
Yes
Yeah.
called
sir.
as a 2.5 layer protocol?
Because it works in both layer 2 as well as router will also receive ARP request. So it is called as 2.5 protocol.
Can ARP
2.5
cross
layer.
a network? Can ARP request cross
No,
from one
No,
network to
no.
another network?
no sir, it cannot
No.
cross.
Okay. So, Venkat, can you tell me about the what is the exact definition of the default gateway? What is exact default gateway?
Yeah. Default gateway is nothing but a router. Like any traffic will go exit from that default gateway.
If someone will ask you what is default gateway, simply you can say an exit point or exit interface of a network is called as default gateway. Is it clear, guys? For you, what is
Yes sir,
default
but
Yeah.
gateway?
it's enough for that
Is it?
in
It is
interview.
enough.
Okay, okay sir.
Okay. So, any other thing? So, on Monday, Lakshman, you will have to search what is the command to configure the MAC address manually on a router's
Yes sir.
interface.
Yes sir.
It's your task so that you
Yes sir.
can remember that we can manually configure the MAC address on a router interface. So one
Yes sir.
thing it's important, not very important for the interview purpose, but real time scenario, which I left in the starting classes to discuss, that is topology.
Star topology, ring topology, like that.
Bus
It's not.
topology,
Uh,
star topology, ring, and fourth one is
Mesh topology.
mesh or
star,
hybrid.
ring, like
most of the ISPs, either they are using this topology, ring topology or hybrid topology. So in bus topology, suppose it's a bus, router is a PC are here. It is connected with PC2, PC1, PC2, router 1, router 2, you can take any device. PC3, PC4. So if they are connected in a serial manner, so this topology will call as a bus topology. But what is the disadvantage of this topology? If PC3 will goes down, if PC3 goes down, then PC2 and PC4 will not able to connect, and PC1 and PC4 will not able to connect. Is it clear for everyone?
Uh,
Yeah.
it will be connected in a single link. Yes, sir.
Yeah, in a single link they are connected. The second one is star topology. That is, here it is a router R1 and R2 is connected, R3 is also connected with it, R4 is also connected with it, R5 is also connected with it, R6 also connected with it, R7 is also connected with it. So all the traffic, if R4 and R7 are communicating with each other, then traffic is passing through which router?
R1
R1.
central.
If R3 and R5 is communicating, then traffic is passing through R1. So every traffic is passing through R1 router. But if what happen if R1 goes down?
All down.
Entire topology will down. Okay, so it is not a good practice to use the star topology. Now we are coming to the ring. Few ISPs in India are using this topology, ring topology. But if they are working in a only in a city, not I am talking about the either BSNL or Geo Fiber or Airtel or Exitel. I'm not talking about these companies, but small level ISPs, service providers are using ring topology. So ring will work in a ring. R1 is connected with R2, is connected with R3, connected with R4, connected with R5, connected with R6. So R1 is communicating with R3. If R2 will goes down, if R2 goes down, so R1 can communicate to R3 with this path. Okay, is it clear? Similarly, if R5 goes down and R2 is up, so R1 can communicate to R3 by this link. Okay, but what happen if both goes down? Then R1 will not able to communicate with R3. So this is the advantage and this is the disadvantage of ring topology. Clear for everyone?
Yes, sir.
Yes, sir.
Hybrid or mesh. Most of the ISPs use this. When you will see PRTG or MRTG diagram of any ISP, then you will see they are using this only. So suppose that here are router 1, router R2, router R3, router R4, and they are connected with each other in a square manner and in a diagonal manner. Suppose that R1 is using this path. Guys, are you there?
Yes, sir.
R1 is using this path to communicate with R4. If this path goes down, R1 can use this path. Okay? And if this path goes down, R1 can use this path. Is it clear for guys?
Yeah.
Suppose R1 is communicate here, R2 goes down. So R1 can communicate directly R with R3. So it will increase the availability.
Sir, all devices are connected with each other. Yes, no?
Yeah, it will increase the availability. Here chances to uh, goes down of entire topology is very low, very low, because three paths are available here. So if two paths are goes down, then one path will be available. Suppose that here R2 goes down, then R3 is available. Suppose that R2 and R3 both goes down, then this path is available for you. Okay?
Yes, sir.
So guys, that's end for today's session, and tomorrow we will continue.